It's wonderful to see so many people come out for such a great cause. How many of you guys have kids, have had kids, little kids? Raise your hand. Right, so many of you know Karen and David, and you've seen the struggles that we've gone through, but many of you, until their diagnoses, probably had never heard of Batten disease, CLN3 Batten disease. For those of you guys who don't live in their house and experience what they're doing each day, imagine if you had a perfectly healthy child like many of you have, and when they were around the age of 4 to 5, they started having vision problems, they started to have seizures, and you went to see your peds neurologist or a geneticist to find out that they have an uncurable pediatric disease and they're probably not going to live past their mid-20s, right? So horribly devastating disease. I've been working in this space for the last 20 years. I tell my husband that the Batten's kids are my children. We don't have any kids of our own because I feel like I really focus my life on helping to find treatments for these kids. So Karen mentioned to you that I now have 2 jobs. I run a basic research lab in Sioux Falls, South Dakota, where we work on Batten disease. But I also, over the last 5 years, have helped to develop a number of gene therapy programs for Batten disease. One of them that is now being shepherded through the clinical process by a wonderful pharmaceutical company in Philadelphia called Amicus Therapeutics. So that is one of the programs that we've helped to develop for CLN3. But For Batten's and your money have helped to sponsor a number of research studies. And Karen and David had just asked me tonight to kind of highlight some of those programs so you understand where your money is going and how vital it is. So even as there's a gene therapy that can potentially help kids with Batten disease, we don't really know how long treatments like gene therapy will last. This is new cutting edge science and we don't know enough about it. So we can't stop working. We have to keep coming up with the backup to the backup to the backup so that we have an arsenal of treatments that we can give to these kids as they go through the course of their disease. So the cons, one of the early projects that they focused on actually augments the gene therapy work. And so gene therapy is a common cold virus. Many of us as adults have been exposed to the same virus that we use for gene therapy for these kids. And so if you imagine if you've actually been exposed to that virus, your body's going to make antibodies because that's what our body does to help fight viruses. And so if you use a drug that's built on that virus, then those antibodies can start to attack that virus and turn off that treatment. So one of the first projects that the Fore Batten's Foundation and you guys funded was to start looking at ways that we can clear those antibodies out of the body of these children. So if they have pre-existing antibodies, if they've been exposed to these cold viruses, that they might also be able to get the gene therapy and be able to be treated by correcting that gene. Now the cons are supporting a joint project between my lab at Sanford and Sioux Falls, a group in Rosalind Franklin University in Chicago, and then a lab in Montreal. That essentially it's a 3-part study using, again, genetic correction. So they use this cool technology at Rosalind Franklin called antisense oligos. And it's a way for, essentially in CLN3 Batten disease, to skip over the bad parts of the mutation and make most of the gene correct. And so the team, the cons are funding the lab in Rosalind Franklin to build ASOs that would skip over the mutations that Amelia and Mackenzie have to hopefully make a corrected gene. Whereas our lab at Sanford has actually made a pig model for CLN3 Batten disease. So a lot of the work that we do historically is in mice, but mice don't actually develop CLN3 Batten disease similar to humans. So in order to be able to screen all these drugs, we need better animal models. So we've started to develop an animal model for CLN3 that we can test some of these therapies in, including the antisense oligos and the gene therapies. And then the group in Montreal is trying to understand the basic biology of what does this gene even do in our bodies? Why do we need it, and why when we lose it does it cause their brains to deteriorate, and understanding what happens to the neurons. So by putting these things all together, what we can do is develop and test more effective drug treatments. They also continue to partner with the BDSRA. Karen mentioned that some of their team is here tonight to look at when these drugs actually go into patients. How do we actually measure response? How do we look at some of the quality of life measures that these patients are going through, whether it's sleep disruption or the seizures that these patients might suffer from, and how do we correct those and monitor those things? So I just wanted to kind of highlight those things so you guys understand, like the money that you're giving tonight and at these events is very important to help drive that research, to help these programs keep moving forward, and hopefully help us move more closely towards a cure.
Good.